Hello everyone, my name is Krishna Davde. Today I am going to show you what I have achieved throughout my research project. The title of my research project is Indexing Techniques for Database System. In this project, I have tried to implement B-Tree, B-Tree why, and try to figure out why B-Tree is mainly used for database systems and over and why B-Tree is efficient than the other traditional methods for searching and inserting. For this, to achieve this, uh, I have used two data structures. First one is BST and second one is B-Tree, and try to uh, with the help of those two data structures, I try to implement indexing around records of files, and I try to see the n time taken by those two data structures for n number of records for inserting and searching. So let's see. So okay, so in the for the for this for this implementation, I have taken one common file called sample.txt file, where I have keep around 10 million records, where in each record there are mainly three fields. I have taken there are mainly three fields. First field is for name field, second one is for age field, and third one is for city field. So in this implementation, I have tried to uh, make make an indexing for those two data structure by taking the name field, which is of type character array or string, as a key for indexing. So we are going to implement indexing on this file by using name field as a key attribute, as a key type. So first of all, let's see, try to make an indexing using BST. So for that, I have to look for the n.h file, where I have set the value of n to be around 10,000, which means I have taken around 10,000 number of records of sample.txt file into the consideration for making of an indexing of BST using BST. Okay, so first make an executable of BST. Okay, and for same for the B-Tree. Okay, and then run those executable. As you can see, BST and B-Tree is taking for 10,000 number of records around more than 1 second for n number of searches. Both data structures are taking less than 1 second for n number of searches, where n is 10,000. Okay, but you can see the difference between the time taken for those n number of searches in BST is around 0.64 to 287, whereas in B-Tree, which is almost negligible, which is 0 point, as you can see, 0 point. Okay, after running those two executables, you can see for 10,000 number of searches, BST is taking 0.64 to 287 seconds, whereas B-Tree is taking 0.00448 second, which means B-Tree is working uh, comparably a little bit efficient. But if I increase number of records to be considered for indexing, let's say if I set the value of n to be 1 lakh, then which means n which means key 1 lakh key to be generated, and at the same time for 1 lakh in searches. So we right now, okay, for 1 lakh we will try to see what would be the time taken by both data structure for 1 lakh records. Okay, so again make BST, again make B-Tree, and run those executable again. So as you can see, BST is taking more time, so we have to wait for a while. Okay, as you can see, my BST executable is running completely, and you can see for earlier for 10,000 records the time taken for searches is very less also. But when I increase the number of records to be considered for indexing here, like for 1 lakh records, yes, so as you can see the time taken for same 1 lakh number of searches is also gets increases. So let's see, try to for same number of records try to make an indexing using B-Tree. So as you can see, for those 1 lakh number of searches, sorry, for those 1 lakh number of records, the B-Tree is taking very less time as compared to BST, whereas BST is taking around 149 seconds, but our B-Tree is taking very less time. It's like it's up to 0.03922 seconds for 1 lakh searches around B-Tree. So you can see the clear difference between BST and B-Tree, as BST is taking more time for retrieval, but B-Tree is taking very less amount of time for retrieval. So why is that so happen? Because as you can see, the height of BST tree is almost O of n. At worst case it is up to O of n, but whereas the height of B tree is very less. For 1 lakh number of records, the height of B tree is around 5. Okay, we can, so which is why B tree is using over BST, because it takes very less time for retrieval. So even not even this, but we can improve the performance of B-Tree as well. If you see, B-Tree is mainly revolve around its property that if we increase B-Tree, okay, why B-Tree is performing very good, very better than BST. All this is just because of its minimum degree property. What it states, let's see, what is the minimum degree property. Okay, as you can see here, T is referring my minimum degree property. So here I have set T to be 10, which means every node of B tree will contain only around at least every internal node of a B tree will contain at least 10 children, or at max twice t minus children. So if I increase t for larger number of records, then our uh, time taken for searches will get reduced. But if I, okay, let's see what happen if I reduce the minimum degree of tree. Okay, here is 10, so I will set it to set on 5. Okay, again make an executable of B-tree. Okay, try to execute it again. So as you can see, time taken for retrieval around 1 lakh number of searches, which is also same. As you can see, which is also same, okay, which is also a little bit effective. But here, as you can see, the height of B trees get increases if I reduce the minimum degree of tree. So you can see the clear difference between BST and B tree. Why B tree is widely used in database systems? Because there you have to keep millions or billions of records at a time, and you have to make searches every around every record, or by keeping by considering one key for searching. That's why B tree and its variants are widely used in database systems for storing large amount of data. Not just this, but also okay, not just this. As you can see, for 10,000 random, okay, for the 10,000 number of records, the height of BST is 10,000, which is of O of n. So we can use another balancing binary search tree for in place of BST, but still the height of B tree would be O of log n if we use AVL tree for indexing. But in terms of B tree, the height of tree gets reduced with the base of m, where m can be a with the base of m, where m can be a degree of your binary tree, degree of your tree. So we can reduce the height by m. So the conclusion of my this project is that B tree works faster for the n number of searches than BST. Thank you.